This video will look at an application of sinusoidal functions that we encounter in everyday life using alternating current in a program called Multisim, which is used in our digital electronics classes. This program that you're looking at here is showing 3 voltage sources, each at 20 volts and operating at a frequency of 60 hertz. And we'll talk more about that in a future video. These wires are connected to something called a 4-channel oscilloscope, which is a device that measures electrical signals, both their amplitude, frequency, period, and other features of those signals. And what I have done, and you'll see why in a moment, is I have color-coded these wires so that we can see that our first voltage will be shown in blue, our second will be in purple, and our third will be shown in yellow, and that is for practical purposes only. When I start the simulation, it will start measuring the voltage sources that I have connected here, but of course we cannot see it. I'm going to double click on scope, and you can see that we see the alternating current moving through the scope, and it obviously looks like a sine wave. What I'm going to do is hit pause on the simulation, but not there. There we go, that's a little bit better. And you can actually see the sine wave here. Because it's moving across, it looks like a sine wave that is probably shifted. It might even look like a cosine wave at some point. And that's because the sine is actually moving. The wave is moving across the scope in real time. Now, what you'll notice is because each 3 of these waves has the same voltage and the same frequency, they are literally sitting on top of each other, and you can't distinguish one signal from another. So the first application that I want you to see from this is the usefulness of a vertical shift. This would be that sliding of a function upward or downward on the coordinate plane. And the way we can do that on the oscilloscope is by changing this window right here, which is like basically a Y positive division there. Now, I've got these wires connected to channels A, B, and C. And so to activate a channel, I click over here where it says A, and I'm going to click upward. Now on the A. So that means I'm looking at channel A, and I'm going to click into this Y. Basically, this is our Y shift. And I'm going to click that upward arrow, and what you'll notice is it's literally sliding that sine function upward. And what that allows me to do is see the sine function or see this wave independent from the other one, so they're not sitting on top of each other. And what I've essentially done is I've put a 1.8 vertical shift onto this function. It separates them. Now, typically, I like to keep them in order. So I'm not going to move channel B, but I'm going to come over here to channel C, and I'll select that. And you can see here that I have now chosen C, and this one I am going to slide down. And we do this in our digital electronics classes a lot so that we have multiple signals and we can see all of them. And so we'll do this thing where we'll color code them, and then we will apply a vertical shift. So all of these are the same function in terms of amplitude, frequency, period, but I have applied a vertical shift to 2 of them in order to separate them. So the blue one has a vertical shift of plus 1.8, and the yellow one on channel C has a vertical shift of minus 1.8, sliding it down on the oscilloscope, which of course corresponds to the coordinate plane.